highlighter's a great thing to have. There's a ton that we're going to go over today. Okay, so kind of expect to see this on your quizzes from this point forward. All right, we're going to go back to connect position, velocity, and acceleration now using integrals. Okay, so we spent a lot of time doing this with derivatives. Now we're going to connect them all with integrals. Okay, so hopefully you recall some of our discussion about the concept of, what was it, Unit 4? Particle motion from Unit 4. We've now added the ability to integrate into our toolbox. We can do so much more with this idea. So just to recall, we start with position, okay, oftentimes referred to x of t, sometimes they call it s of t. That is our position. If we derive that, we get velocity. And if we derive that, we get acceleration. So it goes position, velocity, acceleration. Okay, I'm going to jump down to question 1 here, example 1. And again, totally calculator active. So a particle moves along a horizontal line. From 0 to 8, the velocity is given by this equation, and the position they want you to call s of t. It is known that f of 0 equals -3. That is huge. Okay, I'm going to highlight that, and I'm going to call that my initial condition. Anytime they ask me about s, I have to use this. If they ask about s, I need to use this function. Okay, so the first thing you want to do is get this function typed in y1. So grab your calculator, clear out what's in there. Let's get her typed in y1. When they let you use the calculator, they like to give you ugly functions, so just make sure you get the whole thing in there. X minus 3 ln of x plus 2 plus 2x sine of x squared over 12. All right, and now we're just going to pull back a lot of old material. So part A says find all the values t for which the speed is 5. The speed is 5. The moment they said is, what mathematical term do you think of? If something is something, it's equal to, right? So I want the speed to equal 5 is what they're asking me. Find when the speed equals 5. Now, we have a formula for speed. It's been a while. How do we find speed? Speed. Think of your speedometer. Think about the type of numbers.
Absolute value of velocity.
Yes, Solly. Excellent. Speed is the absolute value of velocity we are setting equal to 5. Okay, now, again, this is the calculator section. The only way you're solving this is with the calculator. When two things are equal, every single time, you will be looking for an intersection. Okay, anytime you write an equation, and we're in the calculator section, and it's an equal sign, we're going to look for an intersection. So let's go back to this calculator and see how it's going to be useful. Now, this is velocity, correct? We don't want it. We want its absolute values. We want to turn it off. Do you see how the equal sign is highlighted? We're going to arrow over to that equal sign, and we are going to turn this off by hitting enter on it. Okay, we don't want that function graphed. We want the absolute value of velocity. So now we got to find absolute value of velocity. Is it alpha top row as well? I'm sure it's got to be in here. I know it's in math. I was just seeing if it's in alpha top row. It's not. All right, I'm going back to math. Math, arrow over to number. ABS is right in there for absolute value. So I'm in Y2. I want the absolute value. Now I'm not going to retype that in. I'm just going to put in Y1 because that's where it's sitting. I want the absolute value of Y1. Okay, so my velocity is in Y1. I turned it off. I need speed, so in Y2 I'm putting the absolute value of what I typed in Y1, and then in Y3 I'm going to put 5 because I want to see where these two functions intersect. Okay, now I'll typically start on a zoom 6, which is my standard window, and then I'll stop it right away. If you hit on, it will stop the graph. Okay, now you might be thinking, why am I stopping it? There's always a domain, but I like to just kind of reset my calculator. The domain says you can only look between 4 and 7, so hit your window button, and I'm going to change my x values to 4 and 7. Right? And then just hit graph. Now the absolute value should keep the whole function above the x-axis, right? It should stay all positive y values. And it'll take a few seconds, but you'll have plenty of time. Make sure to graph 5. And you are looking for the intersection, so just tools you used long ago. Second trace intersect to go get those two values. And look for those two values. Second trace intersect everything with 3 decimal places. I can't reach you, I just have to talk over here. Let's see, I got a t equals 5.621. And I'm getting us t equals 6.520. Move that before I spill that. How are we feeling there? Okay. So you got to have a game plan first. The calculator is really not going to be used for simple arithmetic. All right, you got to have a game plan before you can use this calculator. All right, part B. Write an expression involving an integral. Okay, so then you need an integral. That gives the position s of t. So hopefully lights are flashing and you're saying, okay, I made a note about that. There's something about s of t up here. Use this expression to find the position at t equals 3. So I first have to write just a general integral to get position. Okay. Now, I don't know the best way to do this here. I felt like we've been using this net change formula, and like half of us still aren't getting it. So I'm going to tweak the formula a little. It's going to be the same equation, but I'm just going to say it maybe a little differently. I'm going to say what you want equals your initial plus the initial to what you want. This is the same formula you've been using, but I'm just going to write it differently to see if this sticks in your head better. Okay, what you want equals your initial plus your initial to want. All right, so I want s of t. I want the position. What am I starting with? What is my current position? What did they tell us we start with? -3. I could call it s of 0. Again, like, this is the same formula we've been doing. I'm just trying to tweak it so that we don't miss this. S of 0, and then I would have to go from my initial value of 0 to what I want, which is I'm just going to call t. And if I want position, then I'm integrating velocity. Okay, now just let me be clear. This is the exact same formula saying if I integrate velocity, I get the position at t minus the position at 0. This is the same formula. I just solved for s of t. I just added this over. So you can use either formula. We just got to make sure something's sticking at this point because we've got to get these questions right. So if this helps, what I want equals my initial plus initial to want. Now it wants me to find the particle's position at 3. So I'm going to say s of 3 equals, I'm just plugging 3 into my equation, s of 0, which is -3, plus the integral from 0 to 3. And if I want position, I'm integrating velocity. Okay, so I want the position at 3. I have to start with my initial plus my initial to my want of my function. And then I'm literally just going to type this in the calculator. So I'm going to type this whole thing in just the way I see it. So -3 plus math 9 is the integral from 0 to 3. And again, we're not wasting our time. This is in y1, so we're pulling up alpha trace y1 of x. Okay, we don't want to retype things in and waste, the minute doing that. And I would say S of 3 equals negative 6.263. So just to be clear, this is still the net change formula. If I integrate from 0 to 3 of v of t dt, I get S of 3 minus S of 0. And I'm solving for S of 3, which means I'm just adding this over. So I get S of 0 plus the integral from 0 to 3 of v of t dt. Still the net change theorem that's on the bite-sized quiz every single week. But if that's not sticking in your head, you can say it's the initial plus the initial to want of what you're integrating, and it will work every time as well. Okay. Part C. Find all the times on the interval which the particle changes direction. So there's my keyword, changes direction. All right. Again, the calculator is not useful if you don't have a game plan for what that means. Who am I talking about when we talk about direction? Position, velocity, or acceleration? Who gives us direction? Owen, who gives us direction?
Position.
Position is where you start. That is not a direction. Velocity, yes, sir. If I change direction, the velocity has to equal 0, and the velocity has to change signs. Okay. And I don't care if it goes negative to positive or positive to negative. It didn't specifically say, it just said change direction. So first the velocity equals 0, then the velocity has to change signs. So we're going back to the calculator. This is all done graphically. All right, I'm going to turn y1 back on because I want velocity. I don't need the absolute value or the 5. I can erase those. So I'm just going to hit that equal sign and turn that back on. Do they give us a window? They're telling us to look from 0 to 8. So I'm going to change my window back from 0 to 8 and hit graph. So we're just graphing that velocity function. We set our window appropriately from 0 to 8. And we're looking to see where it changes signs. Well, first where it equals 0. So how many times does this function hit 0? Twice, right? Does it change signs at both of them? Definitely, right? Went from negative to positive, positive to negative. So I need to go get those. So on the calculator, again, those are called zeros. So I'm going second trace 0. And now this time you're playing like the left-right game. Get close to your 0. Go on the left side, hit enter, a vertical line should appear. Go on the right side, hit enter, a vertical line should appear. Make sure your 0's in between those two. Hit enter, and I'm getting 2.341. And then play the game again. Go get that next 0. Second trace 0. So it's all about your game plan. If you don't have a game plan, you've got really nothing on this calculator section. You got to know what they're asking and what your justification is. I've got 6.127. Okay, so again, my justification is the velocity equals 0 and the velocity changed signs. All right, part D. Is the speed of the particle increasing or decreasing at 7? Give a reason for your answer. So speed, hopefully, is jumping out at you. And speed increasing or decreasing is like you're speeding up or slowing down. That's what they're kind of hinting at here. Are we speeding up or slowing down? So we had to compare two things here. Who did we have to look at? Excellent. So I need to know the velocity specifically at 7. I need the velocity at 7 for the grader and the acceleration at 7 for the grader. And then I can answer that question. I need to tell them what the velocity is and what the acceleration is. Now I'm going to do that on my home screen. I'm going to go back to the home screen. Now my velocity function is already in what? y1. So I just need y1 of 7. Okay, that's like saying velocity of 7. I'm pulling up y1, and then make sure you do of 7. I'm getting negative 10.912. And again, make sure you're doing it on your own so you can do it for the homework. y1 of 7. Now, if I want the acceleration, what do I want to do to my y1 function? Take its derivative. So now I want to pull up the derivative. Math 8 is derivative with respect to x of the function y1 when x equals 7. So I'm taking the derivative of what's in y1 at x equals 7. I'm getting negative 10.561. So what can I conclude about my speed now? The speed is increasing. Okay, and I've got to say why. Give a reason for your answer. V of 7, don't say V of t. V of 7 and A of 7 have the same signs. Okay, meaning they're both positive or they're both negative. V of 7 and A of 7 have the same signs. Okay. So it is all about understanding the question before the calculator becomes useful. So I tried to put a very large chart here of everything you need to know, and I'm just going to pull some of them out. Like rest. So let's kind of highlight some of these. When we talk about rest, we're talking about the velocity equaling 0. Okay, so maybe tomorrow's quiz, great idea. I'm just going to pull from this chart. Rest means velocity equals 0. Moving to the right means the velocity is greater than 0. I got to have a game plan for each one. Moving to the left means the velocity is less than 0. All of those three talk about velocity. Okay. Average velocity. I like to call this common sense. I think it is. You are using the average formula of the word velocity. Okay. Average velocity. Instantaneous just means find the derivative of velocity. Let's see. Velocity is increasing. This means I'm looking at the derivative of velocity. That came out funny. The derivative of velocity. Velocity is decreasing. I'm looking at the derivative of velocity again. It would be less than 0. Other key one, speed. That's going to be asked a lot. We just went over that absolute value of velocity. Speeding up is when we compare velocity and acceleration have the same sign. We're just going to pull those out. Velocity and acceleration have the same sign. Slowing down. Velocity, acceleration have different signs. Here's one we haven't talked about in a little while. Total distance traveled. Okay. When we talk about the total distance, we are taking the absolute value of velocity but integrating it. So that is different than speed. Speed is not an integral, right? Speed is just positive velocities. The total distance traveled is the integral. Total meaning you're adding things up. So integrate. Displacement or net change, hopefully that's obvious. Here's that position question, that initial condition. All right, I'm going to call this the initial condition. It's the wants equals the initial condition to want. Changes directions. Obviously, V of t, I don't know why that's not in there. We want to say V of t equals 0 and then changes signs. V of t equals 0 and then changes, I guess we could just say signs. All right, now probably the biggest and most important one is the word farthest. All right, and we have not practiced this in a long time. Farthest is treated like an absolute min or max. Okay. And again, we haven't done absolutes in a long time. When you're asked to find an absolute, you don't make a sign chart, you make a t chart. So x, or whatever, t and f of t, whatever the function is, x and f of x, you have to go back to make a t chart, and you include endpoints and critical points. Right, and we'll get to some questions that have that, but that's the most important one, the one that's worth the most amount of points, is finding these absolutes, and you're guaranteed to have at least one, maybe two of those on every free response as well. Okay, and we'll have a lot of time to review here. All right, flip the page. Let's jump to, all right, let's try number 2. All right, this one is non-calculator. The Space Shot is an amusement park ride that gently raises raises the riders up a tower and then rapidly bounces them up and down using an air compressor. The velocity shot is for 0 to 14 is modeled by a piecewise linear function, and it is measured with v in feet per second. Okay, so this section is measured in seconds, and this velocity is feet per second. Okay, so we're on the same page. Time is measured in seconds, v is measured in feet per second. All right, at what time, if any, does the space shot change direction? So there is my key, direction. Who are we thinking when we talk direction? Position, velocity, or acceleration? Velocity. So velocity has to first equal 0, then velocity has to change signs. Velocity has to first equal 0, and velocity has to change signs. So I'm just going to circle candidates. Velocity equals 0 here, 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 and here. How many of them do we also change signs at? 3. T equals 6, 8, and 10. Easy peasy. Okay, and it says give a reason for your answer. You've got it. You're going to do that first. Give the reason and then go find it. All right, here's the annoying question. At what time in the interval is the space shot the highest? Okay, that is your keyword. This is the annoying question. This is the absolute. And it's the highest, so it's going to be an absolute max. We are looking to see when this thing is the absolute highest. All right, so because it's an absolute, we're now making this lovely T-chart. Okay, so what are we finding? Obviously the time. And if I want to know its height, right, its highest value, do I want its position or its velocity? Position. So these have to go back into position. Okay, so you have to include endpoints and critical points. So just looking at the interval, it says 0 to 14. The endpoints are 0 and 14. And the critical points are every time the velocity equals 0. So I have to include 6, 8, 10, and I already have the 0 and 14. Okay, so now I have to go to position, and I don't have an equation for position, so I have to write my own equation. You have to write your own every single time. This one's semi-nice because there's no initial condition. So if I want position, I would just integrate velocity from 0 to 0 in this case. And that's pretty straightforward. The integral is just 0. If I want the position at 6, I'm going to integrate from 0 to 6 of v of t dt. Okay, so again, an integral represents the area under the curve. So I am looking at the area under the curve from 0 to 6. Just be careful. The scale is counting by 20s on the y-axis. So you could go trapezoid. I know that people don't like that sometimes. You could break these up into triangles if that makes you feel better. I'm going to go triangles and a rectangle. So this triangle is 1/2 base times height. My base is 1. My height is 20. That gives me an area of, does 10 sound right? This triangle mirrors it over here, 1/2 base times height. So I'm going to say that's an area of 10. And I've got a rectangle. If I count the base, 1, 2, 3, 4 by 20. That's going to be a distance of 80. So I would say I have an area of 100 for that section. Then I need the position at 8. So I have to integrate from 0 to 8 of v of t dt. All right, 0 to 8. Now I already have the first 100. Now I have to get this section. What do I know about this area, though? What do I have to do to it? Make it negative because it's below the x-axis. So I have a base of 2. A height, again, they're counting by 20, so 20, 40, 60. 2 by 60 is 120, and half of that is 60. So I'm going to put a negative 60 there. So from 0 to 8, I have 100 minus 60, or 40 for that area. Now I need the 0 to 10 to get that position. So now I got to add this triangle, and this has a base of 2 and a height of 40. 2 times 40 is 80. Half of that makes 40. So that should give me, the 100 minus 60 plus 40 should get me, is that 80? Now think about this. I could argue that I don't have to do the last one. What type of area am I going to have here? Negative. So is it going to be higher or lower than 80? It's going to be lower, right? And I'm looking for the highest. So I already know it's lower than 80. I don't need to waste my time because I can see the highest is going to be 100 feet. And it says at what times is it and how high is the ride. So 100 feet at t equals 6 seconds. Okay, so if you can save yourself some time and not having to do one, that's extra bonus for you there. So again, you're going to start to see more of these absolute typed questions, and we'll just, we've got a lot of time to tackle them here. Part C, find the total distance the space shot travels during the time interval 0 to 14. So obviously, total distance should be jumping out at us. Okay, now total means you added a bunch of things up, right? So that's how I know I'm integrating. So I'm integrating from 0 to 14. The total distance is the absolute value of velocity. That was on our previous page as a reminder. Okay, absolute value of velocity. If I didn't have the integral, then it's speed. But the integral adds it up, which makes it a total distance. Okay, so now I want to go from 0 to 14. I want to add all those up, but I want to take their absolute value, right? So I'm just going to write these numbers down. From 0 to 4 or 6, we said we had 100. From 6 to 8, we had negative 60, but the absolute value is going to make it a positive 60. Then I had a positive 40, and shucks, I have to find the last one here. I've got 1, 2, 3, 4 by negative 40, so that's negative 160, and half of that is negative 80, which is going to make it a positive 80 because I'm taking its absolute value. So let's see, 60 and 40 make 100. There's another 100, so I would say 280 feet. All right, last one, part D. Write expression for the ride's acceleration, velocity, and position on the ground from 10 to 12. All right, let's take an easy one, acceleration. So I'm looking only between 10 and 12, so I'm just going to kind of zoom in that section. I'm looking at this section only, 10 to 12. And I want to talk about their acceleration. So if this is velocity, what am I looking at to get their acceleration? The slope, right? Acceleration is just the slope. So if I look at this, a of t, it's only the slope of that line. Now just be careful, they're counting by negative 20, so my slope would just be negative 20 over 1, or negative 20, sorry. My acceleration is just negative 20. I'm just literally writing the slope of that line. All right, now I need my velocity. Now, I happen to be staring at velocity, so I'm staring at a line. I need to write the equation of this line. So I'm going to do it up here. I'm going to say y minus y1 equals m times x minus x1. What do I already know about this line? It has a slope of negative 20. And all I need is an x and y. You can pick any x and y on the line. I'm going to pick an easy one. 10, 0 is on the line. So I'm going to say x minus 10 and y minus 0 equals negative 20 times x minus 10. So I'm going to say y equals negative 20 times x minus 10. And that represents my velocity. You could distribute if you want, but doesn't matter. So I'm going to go down and say my velocity is negative 20 times x minus 10. So my acceleration was the easiest. I took its slope. My velocity, I'm just writing the equation of the line. Now my position, I have to go backwards, right? If this is velocity up here, to get position, I have to integrate. So I have to start with my initial amount. So I'm going to say x of 10, because I'm starting at 10, right? This started at 10, plus the integral from 10 to 12. And if I want position, I'm integrating velocity. So I have to start with 10, plus the integral from 10 to 12. Now I'm just going to do one more step. I'm going to replace that position at 10 because we know it from this chart. The position at 10 was 80. So I'm going to say 80 plus the integral from 10 to 12 of v of t dt. So we're going to play more and more with this over the next few days, and we'll get better as we go here. Tonight's homework, all right, I don't know if we've done one of these before. If you look at page 361, just give me 1 second. It's called a Big Ten. The numbers 0 through 9 will represent one of these answers. So if you get a 3 for the first question, cross it off, and no other answer will have an answer of 3. So every answer will either be a 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, and you will use it only once. Does that make sense? So if question B, you got an 8, cross off 8, and nobody else should have an answer of 8. Okay. All right, keep bringing those calculators back.